Hello everyone, in this video we will dive into high-level mathematics questions. This paper is considered one of the hardest one in IB examination. However, if you identify the relationships between expressions and apply your work carefully, chances are you will answer all the questions correctly. Make sure to pause the video and try to solve questions before watching the solutions. And if you need help, please leave a comment in the comment section. Let's start with the question 1.
Question 1. This question asks you to use polynomial functions to model some situations in probability. Two unbiased tetrahedral dice with faces labeled 1, 2, 3, and 4 are drawn, and the scores recorded. The random variable m denotes the maximum of these two scores. The probability distribution of m is given in the following table. Find the expected value. So how are we going to find the expected value? If you check the formula booklet, you're going to see the formula. The expected value, you're going to just multiply the number of m with the probability. For example, 1 times 1 over 16 plus 2 times 3 over 16 plus 3 times 5 over 16 plus 4 times 7 over 16, right? We can just calculate the numerator because the denominator is the same. We're going to have 1 plus 6 plus 15 plus 28 over 16. It will be 722, 50 over 16. You can calculate the approximate value. Yeah, it is 50 over 16, 3.1, 3. Let's say 13. Yeah. And an alternative way to represent the probability distribution of m is to use a polynomial function g, where GOT is there is an expression in here. Hence for the distribution m, GOT, yeah. It's given that GOT, this is the probability distribution function, and we're gonna find the G1, right? We will just replace t with 1. So it will be G01 equals 1 over 16 plus 3 over 16, because I know that 1 is inefficient. 5 over 16 plus 7 over 16. From here you can write, it's gonna be 4, 9, 16 over, yeah, 16 over 16, which is 1, right? The next question is, as you see from here, it's asked for the derivative of g function. We're gonna find the derivative of GOT. How are we gonna find the derivative? I know that derivative of t is 1, so it will be 1 over 16 plus derivative of t squared is going to be 2t, 3 over 16 times 2t plus 5 over 16 times derivative of t to the power of 3 will be 3 times t squared plus 7 over 16, 4 times t to the power of 3, right? And yeah, we can just maybe simplify this. For example, we can cancel here the 8, 2. 1 over 16 plus 3t over 8 plus 15t squared over 16 plus 7 over 4t to the power of 3. Yeah. He showed that the derivative of g at the point 1 equals expected value. So we found the expected value, let's say 50 over 16, or yeah. So we will just replace again t with 1. Let's substitute 1 in here. It will be 1 over 16 plus, by the way, I'm gonna write in the common factor, it's gonna be 16, so 6 over 16 plus 15 over 16 plus, it was 28 over 16, right? So when you add all of this number, you're gonna see is 50 over 16, which echoes expected value. Yeah. The next question, a bag contains 2 red balls and 3 yellow balls. 2 balls are selected at random without replacement from the bag. Yeah, 2 balls are selected, and there are 2 red and 3 yellow balls. The random variable x denotes the total number of red balls selected. The probability distribution of x can be represented by the polynomial function g sub x, where g sub x o t, there is an expression in here. Yeah, we're gonna show that g sub x o t is this one, and making it clear how the coefficient of, yeah, this function have been determined. So okay, uh, x is the red ball selected. So for example, I'm gonna write in somewhere here, right? Yeah, let's write in here. So the function is uh, sum of there is y or x. Yeah, there is x from this one. For example, when you plug in 0 into this expression, you will see that the probability x equals 0 times t to the power of 0. And when you substitute 1, probability of x equals 1 times t, and the probability of x equals 2 times t square, right? So the x is the number of red balls selected. We have 2 red and 3 yellow balls, right? And we're gonna select 2 balls. So total number is 5. In this case, for example, here, uh, from total 5 balls, you are choosing 2, but none of them will be, for example, in here, let's say the red one. So we will get all of these 2 balls from the yellow one. So you're gonna write in here 3, choose 2, because the number of yellow balls is 3 times 1, because I know that t to the power of 0 is 1. So how about if we choose 1 red, which means 2 choose 1 and 3 choose 1, because from the yellow balls we're gonna select 1. And the term is t in here. So at the next step, we will choose all of the red balls to choose 2, right? The red balls, number of red balls. And from the yellow balls, we choose nothing. And let's calculate this one. I know that 5 choose 2. Let's remember 5 choose 2, meaning 5 times 4 to the over 2 factorial. It will give us 10. And 3 choose 2 equals 3 choose 1, because I know that if the total value of this numbers is giving the up, which means they are equal each other. 3 choose 1 is 3, plus the denominator will be 10, and 2 choose 1 is 2, 3 choose 1 is 3. I know that if 2 choose 2 or n choose n will give us 1, like it is same with 2 choose 0. The numerator will be 1 again, and the denominator is 10 t square, right? Let's simplify. 3 over 10 plus 6, or you can write 3 when you cancel 2, 3t over 5 times t square over 10. The next question is, an unbiased coin and a biased coin are tossed. The probability of obtaining a tail on the biased coin is p. The random variable y denotes the total number of tails obtained from tossing both coins. The probability distribution of y can be represented by the polynomial function g sub y is given like this. Given that the coefficient of t square in g sub y O2 is 1 over 3, find the value of p. Okay, what's this function? This is probability distribution of y, and y denotes the total number of tails obtained from tossing both coins, because there are a tail biased and unbiased, right? So if it is unbiased, first let's clarify this function. This is sum of some terms. If you replace y with 0, you're gonna see that the probability of y equals 0 times t to the power of 0 plus the probability of y equal 1, right? T. And the probability of, let's write in here, y equal 2 times t square, right? So I will take this. Yeah, take this here. Okay, so we will find the coefficient of t square, right? At the question E. The coefficient of t square is the probability of y equal to, meaning the number of tail, like the probability of uh, obtaining a tail. All of them will be tail. If it is unbiased, it will be 1 over 2. And if it is biased, it's given that is p. 1 over 2 times p will be the coefficient of t square. It is 1 over 3. From here, you can write p equals 2 over 3. Okay. The next question is an expression for g sub y O2. Yeah, we will find, for example, none of them is tail, meaning Uh, the unbiased coin is already will be 1 over 2 because if it is head or tail, it doesn't matter. It's going to be 1 over 2. And at the bias coin, we found that P is 2 over 3, but we don't want it to be tail, so we're gonna subtract from 1 this number, right? It will give us 1 over 2 times 1 over 3, which is 1 over 6. If you want to calculate one of them is tail, it can become from either unbiased or biased. Just calculate it. From unbiased, if it is coming tail, it is 1 over 2, meaning the other one will be not tail. We found that the probability of tail is 2 over 3 if it is biased, so we will write here 1 over 3, which is the probability of head. And it can be also 1 over 2. Let's say the unbiased coin is head, and biased coin is tail will be 2 over 3. From here you can find 1, 2, 3 over 6 or 1 over 2. Okay, for the probability y equal to, we found it at the previous question is already 1 over 3. So let's write the expression for g sub y of 2 equal this number 1 over 6. The t to the power of 0 is 1 plus probability y equal 1 will be 1 over 2 times t plus 1 over 3 times t square, which is this probability. Yeah, we found it. At the next question, the random variable z denotes the sum of the total number of red balls selected x and the number of tails obtained from tossing both coins y. The probability distribution of z can be represented by the function g subset where it's given like this. For random variable z, it can be shown that derivative of this function at the point 1 will give us expected value of z. So we will find this expected value. Yeah, we're gonna find the expected value of z. You see this function v subset ot equals g sub x ot times v sub y ot, right? But we are looking for the derivative of this function. We can apply the product rule. What's that? First, we'll find the derivative of this first function, vox times the second function plus first one times the derivative of the second function. We're gonna replace x or t with 1, which will give us the expected value of z. Yeah, we will find these values, right? Yeah. We know that when t is 1, for example, the function g sub y, you can see we found it at the previous question here, right? So g sub y is, let's write here, when you replace t with 1, you will see that and multiply it with the common factor, all of the fractions, it will give you 1. And in same manner, v sub x at the point 1 will be 1 because I know that we actually found it at, or you can just write in here again. It will give you the 10 over 10 is 1, okay? So you can cancel these expressions and you will just find the derivative of x and the derivative of y, okay? Yeah. And what is derivative of, let's, you can also write here, derivative of x sub x. The function, we found it. Where is this function here? This one. We're gonna take this function. Yeah. The derivative of this function will be 3 over 5 plus 2t over 10. Okay. How about the derivative of y sub y? We found it at the previous question, the derivative, the function for y is gonna be 1 over 2 plus 2t over 3. Okay. So we will use these functions 3 and replace t with 1, 3 over 5 plus 2 over 10 plus for the function y, the derivative of the function, 1 over 2 plus 2 over 3. It will give us, let's calculate here, 3 over 5 plus 1 over 2 plus 2 over 3. Yeah, 1.97. 1.97. Question 2. Informally, the curvature of a curve can be thought of as the amount by which the curve deviates from being a straight line. In this question, you will investigate the curvature of a variety of functions. Consider any function f that can be differentiated twice. The curvature k of any function f is defined by qx. Consider the family of linear functions qx equals mx plus c. Show that qx equals 0 for this family of linear functions. As you see from here, the curvature of a function is defined in this expression here, and there is a second derivative and first derivative at the denominator. So let's find this. Yeah, we can find, for example, the first derivative of g of x is linear function. It starts with mx, so the first derivative is m, and the second derivative is the derivative of m is 0, the constant value, right? In this case, when we plug in 0 into this expression, it's gonna be g of x equals 0 over something, but it doesn't matter. It will give us, you don't need to write even here, qx equals 0. Yeah. Consider the family of quadratic functions h of x, and for this family of quadratic functions is given that, yeah, is given the curvature and the derivative of this curvature. So we will find the maximum value, or the maximum value of qx is denoted by qmax. By solving k prime equals 0, find the value of x where k max occurs. You are not required to justify that this value of x leads to a maximum. To find a maximum value or maximum point of a function, we already need a derivative, and we're gonna equate this derivative to 0. So if you equal this derivative to 0, you will see that since a does not equal 0, I know that 2ax plus b will be 0. From here, you can find x by first subtracting b from the both sides, and we're gonna divide 2a to both sides. X equals minus b over 2a. This is the value where a max occurs, right? Okay, and determine an expression for k max in terms of a only or alpha only. So we found a point where this curvature will be maximum. So we will plug in this point into this expression k of x to find the k max. Okay, let's write this one. K of x equals the absolute value of a times 2 divided by 1 plus 2ax plus b to the power of 2 to the power of 3 over 2. And we're gonna plug in minus b over 2a. Let's find this. 2a divided by 1 plus 2a times minus b divided by 2a plus b, this expression. It will give us 2a divided by, in parentheses, 2a will be cancelled and b will be also cancelled. So the denominator is 1. It will give us 2a, right? Yeah. Next question is state the value of limit x approach to infinity k of x and explain briefly the significance of this result. First check for the limit x approach to infinity, and our function is the same, curvature. Since the denominator increasing to the infinity, it looks like a constant number divided by infinity, which will give us 0, right? And what does it mean? We know that qx is the curvature of the function. Sx approach, we can write Sx approach infinity. The function is close to being straight because it's the curvature becoming 0. The next question is consider the quadratic functions. We can maybe solve this question here. There are two quadratic functions in here, Pox and Qx. State which one of the following statements is true and justify your answer. We will check for the k-mix of these functions. What is k-mix? We found in the previous question for the quadratic functions like this, k-max in here we found it is, yeah, this is for k-max, right? We found 2a, the absolute value of a. In this case, we can write k-max of a equals 2 times, by the way, a is leading coefficient, in here is -2, so it will give us 4. K-max of q is 2 times the leading coefficient of q is 2. It will give us also 4, meaning these are equal, right? Yeah. Consider the function Vox equals ln x. For v is given that there is also curvature function and derivative of this. Determine the exact value of x where Kmax occurs. So this is the same. We're gonna find the equation where the derivative of Qx is equal to 0. And from here we can see that 1 minus 2x squared equals 0. 2x squared equal 1, right? X squared equal 1 over 2 and x equals square root of 1 over 2 because x is greater than 0, okay? Yeah, this is for C1, question C1. And at the second question, we will show Kmax is this expression. To do that, I will write in here, yeah, or the question C2. I know the curvature of this function is x over, yeah, this one, x over 1 plus x squared, the power of 3 over 2. And we're gonna plug in the value that we found in the previous question, this one, to find the Kmax. We can directly write that one. Square root of 1 over 2, 1 plus, it will give us the square of this value will be 1 over 2. Okay, so square root of 1 over 2 divided by, here is 3 over 2 to the power of 3 over 2, meaning 3 over 2 times square root of 3 over 2. If you multiply uh, this expression with the reciprocal of the denominator, it will be look like this, and we can cancel square root of 2, which is square root of 2 divided by 3 times square root of 3. And if you multiply it both up and down by square root of 3, you will see that square root of 6, or it was asked for this value. Sorry, this is 2, not square root of 2. 2 divided by, yeah, from here you can write again 2 times square root of 3 divided by 9, right? Yeah, correct. And consider the function Wox to the Wox equals e to the power of x. For W, it's given that Aox, this is expression, and show that K max equals the same value, okay? Again, we're gonna find the root of this equation when the derivative equals 0. In this case, e to the power of x times 1 minus 2 times e to the power of 2x will be 0, but I know that e to the power of x will not be 0. So 1 minus 2 times e to the power of 2x will be 0. And I will write directly from here e to the power of 2x equal 1 over 2. E to the power of x will be square root of 1 over 2, okay? I don't need to find the value of x from this equation because I already plug in the e to the power x, the value of this number, into this expression, because in this expression there are e to the power of x terms, okay? So I will directly plug in this value e to the power of x into the, let's write in here again, to find k max. I know that at the next question k o x is look like this expression. At the numerator, there will be square root of 1 over 2 again, and the denominator there will be 1 plus 1 plus square of this value to the power of 3 over 2, which will give us the same value that we found in the previous question. So I will write directly the same value, okay? Suggest a reason why we and w have the same kmax. Okay, let's check it. And the function v is ln x, and the function w is e to the power of x. As you see from here, these are inverse of each other. So we can write, yeah, v and w functions are inverse of each other. Yeah, that's it. Because if you, for example, compare the graph of two function, I know that e to the power of x going like this, and ln x, the graph of ln x will be here. And these are also uh, reflection by y equal x, the line. That's why the curvature of these functions look similar with each other. Okay. At the next question, consider a family of curves y equals square root of r square minus x square. R is a positive constant, and show that the second derivative of this function, okay. So I will write the function first in here, y equals square root of r square minus x square, but before finding the derivative, I will find the square of this function. Do not deal with the square roots, and y square will be r square minus x square. You can think like a implicit function and find the derivative of this function or differential of this equation. So how are we gonna find? You can start from the left. Derivative 2 times y times dy over dx, because I need to write the derivative of this function, equals the derivative of r square will be 0 in terms of x, and the derivative of x square will be 2x minus 2x. In this case, dy over dx equals minus 2x divided by 2y, which will give us minus x over y, okay? And to find the second derivative of this function, you can apply, for example, here the quotient rule to find the second derivative. I know that the quotient rule is will be minus 1, the derivative of the numerator times y, minus the numerator times the derivative of the denominator will be y prime divided by y square. If you simplify here, you will see that uh, let's write minus y plus x times y prime. By the way, y prime is, I know, minus 6 divided by y and divided by y square. If we simplify this expression, yeah, it will be minus y square minus x square divided by y to the power of 2 times y, because it will come from the denominator of the up. And I know that minus y square minus x square will be minus r square from this equation, okay? And the denominator is y to the power of 3. Yeah, we can show like this. And the second question is, hints show that the curvature k is constant for this family of curves. To find the first derivative of this function, I know that is given at the beginning of the question, like check, for example, yeah, this one. the curvature. I will take this here. And I found already the second derivative. It is minus r squared divided by y to the power of 3. Okay. It says the absolute value, but r is a positive constant already, so I will write maybe without minus, or in absolute value you can write. At the denominator, 1 plus the derivative of, sorry, the square of the first derivative, it is this one, x squared divided by y squared to the power of 3 over 2. And this is the curvature of the function. Yeah. So maybe we can simplify this one. And I know that the equation is y square equals r square minus x square. From here you can write y square plus x square equal r square. How are we gonna use this? Because at the denominator you can write y square plus x square divided by y square. If you replace y square plus x square with r square, you will see that you don't need to write this minus or even absolute value, and you will see that r square over y square to the power of 3 over 2, which will give us, I will write directly here, r square over y to the power of cube divided by, it will be y to the power of 3 divided by r to the power of 3, because here will give us r over y to the power of 3. I know that 2 will be cancelled. Yeah, y to the power of 3 will be cancelled, and it will give us 1 over r, which is a constant value.
Yeah, we solved all of the questions. Paper 3 exams in recent years are not more difficult compared to previous years. As I told you at the beginning of the video, if you work carefully and follow the structures, you will get solutions easily. Please share the video with your friends, whether they are preparing for high-level mathematics exams or just interested in mathematics. Thank you for watching and see you at the next videos. Take care. Bye bye.